Hi, Algebra 2. You guys are going to be graphing radical functions, and so basically square root and cube root radical functions, all right? To start off, we're going to look at what a parent graph of a square root function is. Remember that word parent graph means without any transformations, what does the graph of a square root look like? So to start graphing any function, we always start with a table, and you can really pick any x values that you want, and I'm going to pick a couple negatives and a couple positives just to show you guys what happens. So I'll start with -1, 0, and then I want to pick numbers that are easy to graph. So I'm looking at my square root function, and I want to think, what are my perfect squares? So I'm going to start with my smallest perfect square, which is 1, and then 4. I'll use the 4 as well, all right? So what I want you guys to think of is, as we're finding our y values, let's say I take -1, and I put -1 into the square root of x, right? What do you guys get when you get square root of -1? That's the definition of an imaginary number. So I actually don't have any values for my graph that are negative because it's going to give me an imaginary number. Okay, so I actually can't graph -1i because that's not a real point for me to actually graph on my coordinate plane. So let's see what the square root of 0 is. That gives me 0. And the square root of 1 gives me 1. And then the square root of 4 is 2. So all I've done is found coordinate points that I can now graph. So let's go ahead and graph these. My first point would be 0, 0. And then 1, 1. 4, 2. And then if you guys think about it, what's my next perfect square? That would be easy for me to graph. So after 4, my next perfect square is 9. So I could also do 9, and the square root of 9 would be 3. So 1, 2, 3, 4, 5, 6, 7, 8, 9 would be out here, and then up 1, 2, 3. Okay? So that would be my next point, which means my square root graph looks like that. So I don't have any points on the left side of my graph because those would be imaginary numbers if I took the square root of a negative number. So I would wind up with imaginary. So the square root graph actually just starts at 0, 0, and then it goes off to the right. That's my parent graph. So without moving it up, down, left, right, or without stretching it, that is what a parent graph of a square root would look like. Let's talk about end behavior for a minute. We're still going to look at two ends. So I am going to start as x approaches. Okay, now I cannot go to -infinity because if I go to -infinity, I don't actually have part of my graph all the way at -infinity. So what I am going to say is as x approaches the left point, which in this case would be 0, right? So as x goes to 0, f of x also goes to 0 because my point is at 0 here and 0. So x is 0 and y is 0. If I look at the right side, as x goes to infinity, I actually do have an arrow on the right side, and my arrow is going slightly upwards. It's going to keep getting higher, it's just very slowly. So if you guys look over here where this arrow is, it keeps going up, but it goes up kind of slowly. So as x goes to infinity, my f of x is also going to infinity. Let's talk about domain for a moment. I'm going to put domain in red. My domain would mean I'm starting here, and that I'm ending going to the right, so I'm going to infinity. So that means my domain starts at 0 and goes to infinity. I am going to put my range in green. So looking at the y values, the lowest my y values go are wherever this point is. So that's the lowest, and that's at 0. And then the highest it goes, well, it's going to keep increasing and going up. So I continue to go to infinity. So I'm going from 0 to infinity. Okay? Now, just like with our quadratics and with our absolute value functions, we can start to transform the parent function. And if you guys remember, I'm going to put over here on the left what we've done so far, so our prior knowledge. Okay? So far, we have a line, AX, and I'll say plus K. All right, the A is your slope, the K is our vertical shift, which is our y-intercept, and that was for a linear function. So that looked like a line. Then we had the absolute value function. So absolute value, and that was y equals, and we had x minus h in the absolute value. The plus k was on the outside and the a was on the outside. The absolute value graph looks like a strong V. And then the other one that we graphed like this was the quadratic function. The quadratic function was y equals, and then we had x minus h in parentheses with a square, and then plus k. And we have the A in front. So all of these follow the same pattern. They just look a little different. The quadratic function was the parabola shape. Okay? And then if you recall, the A, H, and K's all did something a little different to our graph as well. So when you look over here, I'm going to put it in red. A square root function also has the A, H, and K's. And the h is still going to move our graph right or left. The k is going to move up and down. And the a is going to determine whether our parent function is going upwards or if it reflects downward. Okay? So let's do a couple practice problems to figure that out. All right, this first one, you'll notice that you have an a value of -1. If our a value is -1, that means we have a reflection. We also have a k value of -2. And that means we shift down 2 units. Okay? So I'm going to draw my parent function in black, and then I'm going to draw this transformed function in red. So I'm going to make a little note. Parent is going to be in black, and then transformation, transformation is going to be in red. There we go. Let's go ahead and draw it, and if you'd like to pause the video here and try it on your own, go ahead and do that, and then you can check in a moment. All right, so what you'll notice is in black is the parent function. This is just y equals square root of x. In order to draw the transformed function, I had to move every point down 2 and then also reflect it, so it's now upside down. So instead of going up 1 and to the right 1, I went down 1 and then to the right 1. Instead of going to the right 4 and up 2, I went to the right 4 and down 2. So that's how I got the next point and graphed my transformed function, which is the y equals negative square root of x and then minus 2. All right, so that is the square root. We are going to do the same thing with our cube root function. So we're going to start off with a table. And what I want you guys to think of to pick nice and neat numbers to graph is what numbers are perfect cubes. So, for example, perfect squares were 2, 4, 9, right? Perfect cubes would be 1, or sorry, not 2, 1, 4, 9. So for cubes, it would be 1 and then 8, 27, right? We are going to pick negatives and positives and see what happens with a cube root. So for my table, I'm going to pick negative 27, negative 8, negative 1, positive 1, positive 8, okay? The reason why I'm picking negative numbers here is because we're taking the cube root. So what number multiplied by itself 3 times would give me negative 27? So the cube root of negative 27 actually winds up being negative 3. So I do have a cube root when I'm using negative numbers. My cube root of negative 8 would give me negative 2, and so on. Cube root of negative 1 gives me negative 1. Cube root of 0 gives me 0. Cube root of 1 gives me 1. And the cube root of positive 8 gives me positive 2. Let's go ahead and graph these on our graph paper. And let's see what they look like. So of course I can't fit negative 27 and negative 3 on my graph paper, and that's okay. But I can fit the negative 8 and negative 2. And you'll notice the way that they're graphed, they look a little funny. They are going to connect, making an S shape. So I am going to start from the middle, and I'm going to curve up to this point, and then I'm going to curve down toward that point. So they kind of make a really stretched out S shape. Notice how this one does go from negative infinity to positive infinity. It doesn't stop and have a restricted domain like the square root function did. So for this one, our end behavior can go to negative infinity and positive infinity. So I can say, as x goes to negative infinity, f of x also will continue to go down here. It goes down very slowly, but it does go down to negative infinity. And as x goes to positive infinity, f of x also goes to positive infinity because it continues to go upwards. Very slowly, but it does go up. Our domain, I will do in red. We are going all the way from negative infinity to positive infinity. And our range, I will do in green. We are going from negative infinity, which is down here, and we are going up to positive infinity. So we are also continuing to go from as far down as possible, because that arrow will continue taking us down, and then the opposite arrow on the right will continue taking us up. So our domain and range are still going to be from negative infinity to positive infinity, just like many of our polynomials are. So the cube root parent function works very much like all the other functions that we've done. Inside the cube root, we have the h value, which still takes us right and left. The k value takes us up and down, and the a value will stretch. So for this particular function, we just have a +3. So that is our k value, which means that we are shifting up 3 units, okay? I am again going to draw my parent function in black, and then I'm going to draw this transformed function in red, and go ahead and pause the video here so you guys can try graphing the transformation on your own as well. Alright, so you'll notice in black is our parent function. You do not have to graph the parent function every time, but it does help to see it and then to visualize what the transformation is going to look like. So here's our parent function, the cube root of x, and then I've just taken every point on that function and moved them up 3 units. So now we have y equals the cube root of x plus 3 units. Okay? Great. Let's take a look at one more example. Okay. For this one, you'll notice it has a reflection, and you'll notice that the starting point of the graph is to the left 2 and down 1. Therefore, our equation will look like this. I know it's a square root function, not a cube root, because it looks like just half. It's not the S shape. It's reflected, so I have a negative, and then +2 moves it left, and -1 moves it down. Go ahead and push pause and try to find the domain, range, increasing, decreasing, and end behavior, and then check at the end, and I'll see you guys next time.